So this is where we left off in our last video. We talked about soldering, we talked about flux, and we've got all the pins soldered onto our Arduino. So we're going to set that aside. And then today what we're going to look at are these pads right along here. So we have them here, there's some over here, there are some up here and over here. These are 0805 resistors. So a resistor limits current, so it's going to restrict the amount of the flow that can go through this to things like our LEDs, so the LED won't explode, right? Well, so it won't burn itself out, right? We can put in the one that the data sheet says that we should put it in to have this be at the max brightness, or what we're going to do as well is try different resistors with higher values to make it be maybe not quite as bright, because typically surface mount resistors, even though they're pretty darn small, are awfully bright and you might not want to be staring at it all the time. Okay, and it will also help explain what these things do. Now, we are not going to be changing those out in this video, because in order to change them out, we probably want to have an LED here and functioning so we can see what the difference is, okay? So we'll get to that down the road in a different video. Now, in the kit that you might have, if you're just watching this online in the future, then there is a kit for this once upon a time. We have a bunch of different 0805 resistors. So this one right here, if you can see that right there, this is 0805, 100 ohm resistor. What I want to talk about is the 0805. What that means is the little resistor inside here, it's in inches. Everything else in the world seems to be so much in millimeters, but a lot of the stuff in here is kind of both, right? So 0805 means that the resistor is 80 thousandths of an inch, right? So 80 thou by 30 thou. That's pretty darn small. And that's actually probably, I'd say, considered big, which is why I chose that one for these labs here. Believe me, there is a lot smaller than this, so much so to where even the people with the best eyes, they've got, you know, hands that don't shake, they will still use a microscope in order, specifically a soldering microscope, in order to place them on the board. Okay, so I'm going to open this up and I'll show you how this comes. If you order just a few of these, they'll still be in this, but it won't be, this originally is just on one giant spool, and over at DigiKey, they just pull some off, however many you order, and cut it for you. Inside here, inside this package is the 0805 resistor right there, and that's what we got to solder on. So let me get this out of here. So what you do is you take your fine tweezers and just kind of pick up the plastic a little bit. What you don't want to do is just peel it all away, because they're all going to come falling out. Now, if you want to buy a container for these and put them in it, that's fine. I usually leave them in the strip. So I'll knock that out carefully, turn it over so you can see. And then right here is our resistor. Now, if you look at this, there's a little bit, to you it might look white, a little bit of a metal coating on this side and this side. That's what we're going to solder onto the pads, believe it or not, okay? Now, if you can also see on there, there's a number. Now, the number says 101. The way you figure this out is it's 1, 0, and then how many zeros do you add at the end? Okay, so 101 means 10 with one more zero, so 100. That means this is a 100 ohm resistor. So that's how you read these. If it said 102, then it's going to be 1000, and then that would be a 1K, 1000 ohm resistor. So then I'll take this, let's see if I'm framed in shot here, and I'll take this and I'll set it right across that pad there, and you sort of can see how this is going to fit. Carefully, carefully, carefully nudge that into place. So then here's the trick then, right? How do we, here's our soldering iron for scale. How do we get to doing that? Well, it's actually, I feel, most people seem to feel after they get used to it, easier than what we had to do with this, believe it or not. Okay, this wasn't terribly too bad, but once you have this on here, as long as you can stay steady holding it with the soldering iron, you're just going to lightly touch it with a little bit of solder, and that will anchor it on one side. Similar to what we did in the last video with this one, how we pinned down one side and another side, then we were free to solder all the rest of these well, and then if we didn't get the tacks very good in the beginning, we can go back and redo them. The same kind of thing can work here. As long as you just get a little bit there to tack it, then you go to the other side to solder it good. If you had a whole row, it might be very efficient to just tack one down, tack one down, tack one down, tack one down, get it all done, flip the board around, and then carefully do all the other sides. And then if you want, you can throw some more flux on the first side and come back and retouch it if you feel that it's necessary, okay? It's not, like I said, it's not that hard to do. I think that by the time we're done with all the things we have to do on this board, you will be very used to it. Another thing you might want to get, they have, let's see, oops, disaster. So see these here? These are magnifying nerd glasses. Here's some older versions that I had before, but these ones sit on your head better. There's a name, but it's like a lot of things nowadays. It's just somebody makes them and they're just rebranded by whoever. But they work really good, and I can get down, I can get my face down in here. I don't need to quite have a soldering microscope for all this tiny stuff. So then here is what we are going to do. So I got to be careful to make sure I'm zoomed in quite a bit here. I want to try to make sure all this is all framed in. Right here is 100 ohm, 100 ohm, 100 ohm. These ones here are for a different thing we're going to talk about later, but they're also 0805 resistors, but they are 5K. So our 100 ohm resistor is going to fit right in here. It's going to go right here. Something like that, right? We'll scoot it over a little bit. Now, what you'll do first is, so we'll just grab this again, take this off the side, and I grab some flux, as we did before with the pins on the Arduino, put this down. You might even be a little heavy-handed with it because it helps it kind of stick in place if you're kind of shaky. So we're going to hold that right there, and then grab, here, let me get this all situated here. I got things kind of backwards around me. Here's a good thing to understand how to do. So I'm taking the tweezers. Let me zoom out a little bit so you can see my hands. I take the tweezers very carefully and I grab it like this, and I hold it tight, and I don't let go and roll it around, and then I set it back down here and let go. And then you still kind of got to do it like that. Anyways, that's how you flip it, right? Just grab it carefully, flip it over, and lay down. You're always having to do that. Okay, so I've got my solder over here, got my scrubby pad, get my alcohol out of my way, my flux is over here, got my tweezers ready to go. Flux is, soldering iron accessible. Let's get zoomed back in. So grab this, lay it there, hold very still. I'm grabbing some flux. God, why do I keep saying flux? I'm grabbing some solder, and I'm going to move it over just a little bit. There we go. Keep it nice and straight, and touch a little blob right there. It doesn't matter that it's a little blobby ball. Yeah, that looks okay. Then we'll go ahead and turn this around, but normally what I would do would be touch this one, do the next one, do the next one in place, because like motions are going to be a little bit more efficient. And then I could flip the whole thing around and do the other side, okay? But I'm just going to flip this one around, do the other side, Then I'll show you how to do a cleanup on this one and how it looks afterwards and make the solder joint look a little bit nicer, and then we'll move on. Okay, now we've got the other side here. I grab a little bit more solder, and I'm going to put my tweezer right on top there. Then I'm going to come in here from the side and just touch it again and make another little blob. The reason I do this with the tweezers, the 0805s probably not so much, but as you get smaller, if you hold this on here too long, you can have the heat transfer through the resistor, melt the other side, and just shove the whole thing off. Kind of knowing that helps if you need to desolder. You know, if you do need to desolder one of these, just get a blob of solder on here and touch it. They're small enough that you can just touch it from the whole side and actually span both solder pads, and it'll just kind of go like this and kind of melt both of them and just swipe it away and then kind of get the resistor up there. These resistors, I think, cost something like a little bit more than 1/10 of a penny. Right? So, I mean, if you do have to lose one, it's not that big of a deal. Okay, if you can hear that, I'm cleaning off the tip of my soldering iron, and then I come by here, and then I just give that a swipe. And maybe I clean it off, and maybe I'll do it again. If it starts to look a little bit dry, so I guess you'll kind of determine that yourself, you know, what that exactly means. I have to keep trying to reposition this thing. Add some flux. So clean that off. I'll show you what I mean. So you just blob a little bit more flux on there. You really can't have too much because we're going to clean it anyways. So you go like that, just swipe it, and then it will be nice and shiny. Now this eutectic solder, some of the 6337, that's a ratio of solder to lead to tin. Am I in frame? There you go. Sometimes they are a little bit gray by default, but just the idea being you want to have a nice clean solder joint, because if it does look extra gray, that's the oxide layer that I was talking about in the last video. So that is okay. That's probably pretty good. The things you want to watch out for, you know, having the blobs on there like we had in the beginning, that's not a big deal, but it is kind of nice. It just looks nice if it's a little bit lower level. Make sure that your resistor is as straight as you can get it, but mostly, you know, as long as it's touching, that's just aesthetics. If all of your crap is crooked, if I'm your QA, I'm going to assume that when we get, when I get to things like these NPN transistors or other things that are smaller, or, you know, some chip, you know, that has a million legs on it, if I know that that's your quality of work, then I'm really going to second guess anything you do that's at a fine pin pitch. So yeah, keep them nice and straight. Also side to side, you want to keep them within the boundaries right there. So that's pretty typical. But also watch out for the thing being, you know, up in the air, kicked up. A thing that will happen, they call it tombstoning in the fab shops when they do this by machine. It's interesting that you could heat the whole board up and everything melts, but if it cools, it has to cool down at just the right rate. Otherwise, what will happen is one side might cool faster than the other, causing it to pull up in the air, and it can go straight up, and it will look like a tombstone. Okay, that's probably it. I'm sure there's more things to, you know, yammer about, but that's probably good for now. Oh, there is another thing. The numbers, I wasn't even paying attention to it, but it might be convenient, again, from a QA standpoint, that you keep all of your numbers going the right direction, so anybody later down the road wanting to check this out to make sure that you put the right value in there, they can read them clearly, right? Okay. Well, let's get my little handy paper towel out here and some alcohol, and we'll clean this off and take a look at it. Again, I really need to have some Kim wipes. This just happens to be a paper towel. Here is another nice thing about surface mount components. I can come back with, I can get my paper towel a little bit wet with alcohol, and I can come by and I can clean that surface off really nicely without having to worry about it snagging my cleaning towel. I guess, right? As opposed to these guys here where they're all, you know, sharp, right? So let's see if we can get a good zoom on that. That's what we want to have. You see? Okay, so I will move this out of the way, and then I'll go a little bit quicker on this now. But what I'm going to do is just drop out my next 3 resistors, or 2, right? Put one here, and just do what I said before. I'm going to tack one side, tack the other side, and just keep moving. Where is, let's see, I already had an extra one out here somewhere. Here we go. Okay, so there's one. And there is another one. So watch this again. As I peel this back, you just roll it over and you kind of flex it. It should just fall out. Now this little flappy bit right here, if you want to save these things, maybe put a little piece of tape on it. Okay. Oops, dropping things. So right here on that 100 ohm, that one right there, grab a little bit of solder on my iron, put it right in place, touch it. That one's a little crooked. Here's this one, it's upside down again, so we got to do our technique. Now I got to put my other hand down because you got to be able to flip it nicely. It's probably guaranteed you're going to shoot these across the lab. Okay, grab. Hold, solder. Okay. And then flip the board around. Do I still have some solder on here? Just a little bit of blob. Boom right there. Boom right there. Clean this thing off. Clean that off. I really like it to look like a nice little fillet rather than a ball of goo. And there you go. 2 more little guys on here. Inevitably, you are going to have to learn how to desolder these because it's really easy to start getting into some kind of a motion and solder them on the wrong pads. Okay, so just know that that's going to happen, and that's literally part of this exercise. So for now, go ahead and solder on all the 100 ohm resistors that you see. Then we're going to move on to the 5K. So the 5K are the same as these, and you could just go ahead and start doing that, except in the kit that we happen to have, again, you know, if you have it, you'll notice that there actually isn't a 5K ohm resistor. There is, what, a 1, a 3, a 6, and a 10, and maybe 100, something like that. Anyways, I want to come back in the next video to do these to explain what the purpose is. Oh, by the way, I almost forgot. Don't forget about these right here. We have another couple current limiting resistors for these LEDs here. Okay?